AP Chemistry Stoichiometry Review, Balancing Chemical Equations. Let's burn some butane. That means we're going to be taking C4H10, which is butane, and combining it with oxygen. And we're going to be turning that into the common combustion products, carbon dioxide and water. Now, if you took a first-year chemistry class, you should know how to balance it. I'm going to walk through it, keeping track of some numbers in my head, so repeat this procedure if you need to. But then the main point that I want to show is what it actually looks like and why it matters, conceptualizing the math, which seems to be the weak point for a lot of AP Chemistry students, and it's the focal point of the new AP Chemistry test. So if we start with 4 carbons, we should end with 4 carbons. Imagine a 4 there. We are balanced with respect to carbon. Starting with 10 hydrogens means we must end up with 10 hydrogens. However, these are paired up. Therefore, we will have 5 pairs makes 10. That's a 4 there and a 5 there. If we can simply total up the number of oxygens, adjust this number so it fits, we will be balanced. Because if I change this number, it does not affect anything else. We should be good to go. 4 pairs of oxygens makes 8. Plus 5 single oxygens makes 13, giving us a molar ratio of 1 to 6.5 to 4 to 5. Doubling everything gives us whole numbers for a final answer of 2 to 13 to 8 to 10. The reason I covered that so briefly is because most AP students can already do it. If you couldn't, follow the logic by repeating that progression again, and this is a relatively hard one, sometimes known as a double everything, balancing chemical equation. What I'd really like students to have an awareness of is what that all means. That means if you don't use those exact same ratios, 2 molecules of this for 13 molecules of this, the reaction will not proceed smoothly, meaning that there will be some excess oxygen or some extra carbon. This is the perfect ratio. And I've created a PowerPoint animation to show what that all means. That is why a chemical reaction, or this is evidence that a chemical reaction is simply a rearrangement of atoms. What do we have here? We have the 2 butane molecules, C4H10. We have the 13 oxygen molecules, 3, 6, 9, 12, 13. That perfect ratio gives us nothing but product and no carbon dioxide, no butane, no oxygen left over. What molecules are those? Those are our water molecules. These are our, carbon dioxide molecules, CO2. These are our water molecules, H2O. Therefore, the reason we do this is so that we don't waste anything, is one way to look at it. 116 grams of this, what did I just do? I turned the moles into molar masses. 4 times 12 is 48. 10 times 1 is 10, 48 plus 10 is 58, times 2, meaning that 2 moles of butane would weigh 116 grams, multiplied by 13 times 32, wow, 10 times 32 is 320, another 3 times 32 is 96, 320 plus 96, I believe it's 416 grams. Every 116 grams of this requires 416 grams of that. And if you do that ratio, you have the right number of molecules, things will go well. I hope that cute animation helps you to understand why we need to balance chemical equations.